DBCO is an international project supported by the 2020 Horizonte program of the European Committee, implemented by the GIZ in cooperation with 13 organizations with experience in 4 continents. The main goal is to establish a closer cooperation between technology European suppliers and biogas stakeholders in participating countries. The project works through different initiatives like a digital platform, seminar development, technical meetings and visits to plant in different countries. On their website you can access to different documents, dossiers and developed webinars.
Continuando con las visitas virtuales del proyecto DBCO, hoy los traemos a la provincia de Santa Fe, específicamente la zona de Venado Tuerto, donde van ustedes a tener la oportunidad de ver una nueva planta de biogás, en este caso alimentado por otro tipo de materia prima procedente de toda la zona de producción de semilla. La zona de Venado Tuerto se caracteriza por tener varias plantas semilleras de producción de semilla para siembra de alta calidad, y el residuo de esas semilleras que se procesan en planta, fundamentalmente la chala y el marlo, es el principal constituyente de la alimentación de este tipo de plantas. Así que, sin más, los invito a conocer y a visitar la planta de Seed Energy acá en Venado Tuerto.
Estamos ubicados en Venado Tuerto, Departamento General López, provincia de Santa Fe. En este momento estamos en la planta Seed Energy de Venado Tuerto. La empresa se dedica a la inyección de energía eléctrica a la red nacional a partir de la generación de biogás generado por los residuos de las semilleras. En este caso la materia prima sería la chala y el marlo, este desperdicio que genera las semilleras. Hoy tiene una disposición en planta y a raíz de eso se colocan dentro de los fermentadores que tenemos acá en la planta. Eso genera biogás y el gas hace marchar los motores que tienen acoplado un generador eléctrico y ahí sale la energía a la red nacional. También podemos decir que es una economía circular, ya que de ese mismo digestor sale un fertilizante en 2 presentaciones, sólido y líquido, con alto contenido de nutrientes, al cual se puede aplicar en el campo directamente.
The biogas plant of Seed Energy has been made with Italian technology of maximum quality. Unlike conventional maize for commercial use, that is dispersed in the field through integral combines that thresh it and separate it from the cob and the husk, the maize used in planting is harvested whole and it is transferred to specialized industries in the production of hybrid seeds. In these plants, they proceed to separate the husk while the grains are detached from the husk. Due to the large volumes handled by these companies during the production campaign from January to May, high amounts of cereal waste are generated which must be properly arranged. These are very low density materials because its transportation it is very difficult and inefficient. For this reason, the layout of the treatment plants at a point very close to the processing areas is extremely convenient. The other co-substrate that is used also comes from agro-industrial plants which transform vegetable oils into biodiesel. This process generates glycerine as a subproduct in a non-pure form. If they don't make the purification of this material, it becomes a waste that must be properly disposed, because it has a great polluting power. In biogas plants, glycerol acts as easily digestible biomass, increasing the production of gas. The maize cob and the husk take up a large physical space due to their low density. Trench-type silos are used in a biogas plant with the concrete floors and walls to compact and store them properly in order to have material available in a good condition throughout the year.
La materia prima que recibimos de las semilleras, hay un operador logístico donde sale directamente del semillero y viene a cada planta, donde es acopiado en trincheras. A ese material se va humectando con un poco de agua para que ayude a la compactación y así que no entre aire para que el material se ponga feo. Eso ayuda mucho. El semillero con el que probamos esta campaña genera más o menos entre 10 y 14 mil toneladas de biomasa y trabajamos con los 3 semilleros de acá de Venado Tuerto, al cual generan un gran volumen y con eso, digamos, ya estaríamos cubiertos en cuanto a la generación, más la ampliación que está en su futuro.
The cob is a material that does not require special condition to avoid possible degradation. On the other hand, for the husk, several silage and compactation tests have been carried out in the search of properly preserve it, since the supply is waste and is not stable throughout the year, and therefore a stock is required to ensure the loading of the digester the 365 days. The storage capacity of the silos in this unit is a total of 9,000 tons between the 3 concrete trenches. Glycerol is stored in a special tank, so it's available when mixing between the 2 co-substrates. Input proportions are analyzed and recommended by plant technical operator in order to achieve an important production of biogas, not causing setbacks in fermentation.
El proceso es muy simple, se alimentan a los digestores 70 toneladas de biomasa diario, se van agregando al carro de carga, eso luego es ingresado al fermentador principal por medio de un sistema de alimentación que trabaja con bombeo, luego pasa a un tanque secundario y del tanque secundario viene a la estación de prensado donde obtenemos el fertilizante.
Those 70 tons of husk and cob make a mixture which is supplemented with 4 cubic meters or 5 tons of glycerol, more 25 cubic meters of water. These can be supplanted in part by recirculation of digestate taken from the liquid biofertilizer storage pond, adding moisture and nutrients to the mix. This material is placed in a loading hopper. Front loaders are used to supply it, then move inputs from the storage silos to the feeding system. An electronic system operated with load cells alerts the operator when enough volume has been inserted to start the process of preparing the compound to load the fermenters. A critical issue for this plant was achieving the proper grinding of husk and cob, since it is very light and fibrous waste. In the case of the husk, is separated in threads. Improper processing of this could cause superficial crust in the fermenters and makes difficult to operate the entire system. After trying different alternatives, a German disposer was selected. It has 2 mills in series with 4 changeable blades and a honeycomb grid as a counter blade. This equipment allows a very good grinding of vegetal material. That residue is joined with a digestate recirculation stream so as to form a total mixture in liquid phase before entering the digester. The digester is fed by pumps and there is the possibility of alternating an upper and lower load of the primary digester. Finally, the glycerine is fed in a differentiated way through a pump suitable for its transporting. Each digester has 3 22 horsepower agitators to keep the biomass moving which is being processed. These mixtures are equipped with systems that allow varying the direction of the internal propellers that produce the agitation and homogenization of the material inside the fermentation tank. The hydraulic retention time or average permanence of digestate inside the biodigester is 70 days. During that period, different types of bacteria decompose the raw material and release methane and carbon dioxide as main gases. The plant has two tanks, the primary and the secondary one. Both has a capacity of 4,600 cubic meters, with a 30 meters diameter and 8 meters height. Made in concrete, they have an internal layer of insulation and an external finish in sheet metal. This coating allows to increase insulation, reduces heat demand to maintain the temperature, and avoid oscillation inside the tanks. They are covered by a special double plastic membrane. The first allows to contain the gas, while the second forms an upper chamber of pressurized air, which is regulated by blower motors continuously working, next to some outlet valves regulated like inflatable for kids. The pressure of these two chambers allows a storage of the generated gas without losing the dome outer curvature. For optimal processing and good biogas production, a certain temperature is required inside the biodigesters, which must be warranted through the contribution of external agents, since the reactions do not generate heating. In this case, part of the heat recovered from the power-generating engines is used to maintain the internal temperature of all tanks. The temperature established for perfect operation is 48 degrees Celsius, and that heat is supplied by external exchangers to the tank. The heat conductor is the water that circulates between the exchangers that recover the energy contained in the exhaust gases, motor cooling ducts and heating coils of the digestate mass. The temperature is constantly controlled, while the automation and control systems allow to achieve a stable graduation within all tanks, independent of external ambient temperature. The system is completed with the help coming from the insulation of all biodigesters to avoid loss of thermal energy.
Bueno, una vez que obtenemos el gran volumen de biogás, por medio de un analizador, testea la calidad del gas para poder ingresar a los motores. Eso se limpia, se purifica y entra a los motores, donde ya tienen una marcha, digamos, de 24 horas. Los motores no paran, están encendidos durante todo el año, salvo que tenga algún mantenimiento preventivo. El resto es un proceso continuo.
This biogas requires a series of treatments before being used by the engines. Within the biodigesters, minimum proportion of air are injected over an internal nets containing aerobic bacteria to capture most of the generated hydrogen sulfate. When opening the digester during maintenance periods, these nets can be removed and cleaned. Since the comfort of hydrogen sulfide is minimal due to the type of raw material used, this plant does not have other additional operating units. When leaving the digester, the gas is cooled by specific chillers to remove the moisture content by condensation of water vapor that is collected and extracted. Then it is filtered and the pressure is adjusted to finally feed the generator engines. The composition of the biogas is monitored by a gas analyzer. On average, it is 52 to 54% methane, 0.5% oxygen, 46.5% carbon dioxide, and 20 parts per million hydrogen sulfide. The average production rate is 1,087,995 cubic meters per hour. This generates 1,760 kilowatts. Fermenters 1 and 2 produce 80% of the total biogas daily generated. The design capacity of the plant is 2 megawatts working 100%, and there is also a possibility of expanding the project. With this structure, the plant would produce 3.4 megawatts. The plant is now ready to expand its production with the construction of an additional primary and secondary digester, mirror-mounted with currently operating modules. Loading systems, sewage lagoon, solid separation and material storage bunkers have sufficient capacity to serve the two future complete biodigesters. The biomass source is not limiting due to the proximity of the maize separation and classification plants of important seed companies. The entire system is assisted by a special room where the different pipes that lead the material join. They use German screw pumps to drive all fluids of the process characteristics besides water. Pneumatic actuator valves and electric engines allow full control of load movements, discharge, circulation and heating of biomass. The set is sized to also assist in the future expansion of the plant. The biodigesters are remotely monitored and operated through a general control room that receives all the information. Various actuators can be actuated from there, pumps, motors, and mechanisms in order to achieve optimal feeding, maintain the temperature, and regulate all the parameters that make the correct operation. All information collected is streamed online, facilitating external virtual monitoring of the plant behavior. There are digester and post-digester field register sensors, operating temperatures, valve positions, and engine condition. Thus, the European provider of applied technology has the ability to do remote monitoring. The plant has a number of internal combustion engines specially adapted for continuous operation with biogas that generates electric power that, in the case of Seeds Energy, are own equipment. They are assembled inside specially conditioned and insulated containers to reduce noise generation as well as strong temperature fluctuations. The individual capacity of the generators is 1000 kWh, and each unit has its own ongoing maintenance plans to ensure optimal performance, avoiding breakages or failures that could imply the interruption in the generation of electricity. In case of an eventual engine's out of service, there is a security torch that ignites and combusts the fluid, thus avoiding the release of onboard methane into the atmosphere. The digestate coming out of the biodigesters is separated by two press screw systems, adjustable through a weight controller that allows to graduate the amount of fluid removed. The liquid fraction accumulates in an uncovered waterproofed lagoon, which has a total capacity of 11,000 cubic meters, equivalent to the total volume of fermentation. This material is extracted by special pumps dedicated for the loading of digestate distribution containers. So, the solid fraction is stored in a trench built with selected soil to send with distribution trays to different commercialization points. The plant has its own transformer sector, which allow the voltage to be raised from 380 to 33,000 kilovolts in order to minimize transmission losses. All power supply management is remotely monitored by the commercialization and distribution company, CAMESA, by two systems. Based on energy delivery reports, operating outputs and more, the administrator bills the provision made by this company. The biodigester have been built by a national civil engineering company specialized in handling reinforced concrete for large volume cylindrical structures called Arinco. The electromechanical installation also comes from a local supplier. Special pumps, grinders, agitators and power generators are imported mainly from Italy and Germany.